In this video, we'll be talking over some of the harder MC questions in physics IB exam. So the first question is a topic 1 uncertainty exam question. So we're given that V equals to pi r squared h. And we're given the uncertainties of V and h respectively. So our first thing to do is to ignore the pi because that's a constant. And we have V over h square root equals to r. It is important that we rearrange equations before adding the uncertainties, because if you don't do this, one of the wrong methods would be that we have 10% here equals to r squared plus 6% delta. No, it's not like delta r squared. Let's put this in here. And then we're going to go divide it. We've got 4% would be delta r squared over r squared, which is 2 delta r over r. And then we're going to think that the answer would be 2%. But this is not true because uh, in no propagation would you actually minus a uncertainty. It always only gets bigger. So we have to rearrange it, but this is clearly wrong. So based on the sum of relative uncertainties, because it's a division operation, we get that to 16%. And based on the power rule, we know that when it's taken to a power of n times, the uncertainty gets multiplied by n. So we multiply by 1 over 2. Equals to 8%. Therefore, D. Remember to take the method on the left and not the method on the right. Now, for the second question, it's a topic 6 circular motion question. So it is a constant speed as suggested in the question, which means that mv squared of r equals to centripetal force is constant. This is a uh, very important note here, and it's a vertical plane, which means that there is a weight around it. See, weight. So let's suppose that consider balls in these 4 positions: weight and weight. And we then have that this F net would be in this direction for each of this ball, always pointing towards the center. That's what centripetal force is. Now, so for A, it's clearly not true if you consider the bottommost case. If there was a zero force applied by the rod, then there's only going to be mg pointing downwards, and it's just not going to move up, so clearly not A. Now, for B, so B, we're going to explain why it is not true. C as well. So if you consider bottommost case, the most obvious solution is that the F rod would be here. As a result, the F net would be F rod minus mg, giving us in the direction pointing towards the center. For the case at the top of the loop, it's also true. Call this F rod 1 and this F rod 3. F rod and mg are in the same direction as F net. So for the left and right cases, in order for the resulting vector to be placed towards the center, F rod must be in this direction. Because if you consider it like this, we can split the F rod vector into this and then this. So these two vectors get cancelled out, resulting in a F net pointing towards the center. As a result, it can be seen that F rod does not always point towards the center, as displayed in the left and right cases in this diagram. So, not C. And then we'll be talking about the magnitude. So at the very top, the F net would be F rod 3 plus mg. At the bottom, F net would be F rod 1 minus mg. Because mv squared over r is constant, as you can see, we wrote it down before. So we get this. Now, based on this equation, it is very obvious that f rod 3 does not equals to f rod 1. Therefore, it is not B. As a result, the only logical result would be D. Now, this is a topic 3 question about momentum. A ball with mass m moves horizontally with speed u. It hits a vertical wall and rebounds in opposite direction with speed u. And you want to find the magnitude of the average force exerted by the wall and loss of kV. So we know that force is delta mv over t, in this case, m delta v over t. So because it is given in speed u and speed v, which are magnitudes, so we need to put in the signs ourselves. So let's assume that this is u and this is the wall, and it travels back out at speed v, which means that speed v would actually be negative v velocity. Yep. So applying this, which means m v final minus v initial over t, and we will get that f would be m negative v minus u over t. Because it's asking for the magnitude, we get that it is m v plus u over t. So therefore, it will be these two cases. So let's clear the stuff here first. Now, for the kinetic energy, change in Ke would just be 1 over 2 m v squared minus u squared, where v is final velocity and u is initial velocity. It doesn't matter if it's speed or if it's velocity because it gets squared, so the direction does not matter anyways. So but because it's asking for the loss, and as we know, v is less than u, so that's actually already negative. And as for the loss of Ke, we're going to know that it is change it around. Therefore, the solution would be A. For this question, it is a work problem in which two bodies of different masses run up a stair of steps. So we know that power is work over time. In this scenario, let's just assume that is a slope that they're moving up of, right? So this is the same height, and the work done would be the work that it takes to walk up the slope. Have a mass m, and let's have a mass 2m, just a greater mass. So this is the brother, and this is the sister. So by moving up the stairs, they do the same amount of work. No, actually they don't. My bad. For the brother, the amount of work that it does is mgh. For the sister, the amount of work that it does would be 2 mgh, because gravitational potential energy equals the mass times gravitational constant times height, and because the sister has double the mass, it does more work. So it's either C or D. Now, because power is work over time, and we know that they took the same time to move up the flight of stairs, therefore time is the same. So the sister develops more power, leading to an answer of D. For our last question, this is a force or is a mechanics question. There's actually two ways to do this. So there's actually one way. So the force, let's draw a force against displacement. So increases from 0.5 to there. So this is how it increases with displacement until it moves a distance of x. Now the work done would simply be area under the curve, which would be, if we consider this, so it's going to be F area. So it's going to be F plus 0.5 F times x over 2, which is the formula for a trapezium. So this gives us 1.5 fx over 2 equals the 0.75 fx, results in C. Now it's very important to note that the first line, increase uniformly from 0 to a maximum value of f, is actually a trap. I will tell you why. When it increases from 0 to a maximum value of f, the object does not move until the force exceeds 0.5, which means that from f equals to 0 to f equals to 0.5, the displacement is still 0. It's a static friction. There is no movement. Therefore, work done in that period of time is 0. From f equals to 0.5 to f equals to f, the displacement is x. Therefore, work is positive. So many students would go f equals 0 to f equals 0.5 f. They draw a diagram. F equals to f to f equals to f. They draw a diagram. This is f 0 x, and the conclusion they get is that it's fx over 2 or b, which is not true.